Thank you, Aaron. So as you can see, I'm going to talk about basically applied RX 310 today. So we've got fire behavior, fire effects, and burn severity indices. And so if any of these terms aren't things that you think about all the time or about measuring, it's kind of like RX 310 applied, really. So the main questions that focuses on are how are fire behavior, fire effects, and burn severity linked? And so fire happens all around the world every year. It's happened for a long time. And researchers like myself and Ken and Nick go out and set up these complicated experiments time and time again. We build widgets in the ground. We set up these fancy looking long arc things in the forest, and we burn them. And then we spend months, sometimes years, going back out there looking at the fire effects and trying to figure out how they relate to fire behavior that we observed at a couple points where our widgets were placed. And so I'm also on an engine in New Jersey, and usually I come back and I'm talking about my data and how excited I am that I measured something really well somewhere. And then somebody will go, all right, well, Dr. Scientist man, tell me why this happened here, or like getting outside of my research plot, you know, so what's going to happen here in 3 years? How many of these trees died over here? Why, you know, how many died over here? And I'm like, that wasn't my plot. And sometimes it gets really hard to extrapolate our research to all these other parts of the landscape. So this is just a really simple map I threw together last night with New Jersey. These are all the points that I've collected data at over the past 10 years. There's somewhere around 1,000 points. I didn't actually count them all. But if you add up the average area of those points, it probably comes out to about 20 acres of data, like coverage. And then that's where all the prescribed wildfires occurred across the landscape in the past 10 years. And I'm actually missing a bit from this past year. But it can be really hard to infer from our data what's happening elsewhere on the landscape, especially in wildfires that we can't get out to and take pre-fire measurements and you know, set up fire behavior widgets. But it's still important. And I'm not trying to say that the research that we do, you know, it's very good for finding linkages, answering fundamental questions. But from a monitoring standpoint, it's not always very easy to extrapolate to places that we weren't at. And so what's happening in between all of our research plots? And how can we take advantage of all this fire that's on the landscape and learn from it? You know, so there's been millions of acres that have burned in our landscape since the dawn of time, and we're still trying to figure out, you know, some, you know, what's changing over time. So I started looking at, so I started my dissertation around 2010, and at the time, burn severity maps were kind of getting big. And if you haven't seen them, here's an example of one. Here's another one. And they're making these neat color-coded maps that show basically red is where there was more stuff happening from the fire, and green is where there was less stuff, and yellow is kind of in the middle. And so nobody had really applied that in our neck of the woods. This is getting used a lot out west. And so what burn severity does is it allows us to sort of differentiate these regions of effects within fires without actually, we can estimate that without actually having to go there. And that helps monitor how fires vary across the landscape. And so you can measure it in the field with a pretty simple field sheet. And as you use that field sheet, you calculate an index based on observations that relate to effects observed in the forest. So I'm sure you've been out there and you've seen, like, yeah, the fire really hammered over there and it didn't hammer so much over there. And it doesn't take a rocket scientist to know that there was more energy output, you know, in this place than where you still got green leaves on the shrubs. And going out there and looking at this time and time again, like, we all know it, but how do you quantify what you're seeing out there? And So here's a burn severity map that I created for New Jersey. This is the 2007 Warren Grove wildfire. This is our this is one of the biggest fires in recent history of the Pine Barrens. Burned about 18,000 acres. And so where the map is brightest is where there was the most impact ecologically. And here's another fire, the Adsine fire, that happened in that same year, a little bit later. And you can see it's really bright. You can also see that these are the pixel values over here. So if we go back, this one had a lot of high severity pixels and not so many low severity pixels. This fire's on the same scale. It got actually a little bit more severe, but it has a much more homogeneous distribution of effects. And then here's just a prescribed fire from the dormant season that was fairly cool. And here's our plow lines that we lit off of. And you can see it's showing a much lower impact. So my question was, how does this, we got a pretty map now, and that's great, but just because you've got a pretty map that, or pretty data that fits your preconceived notion, is that truth? Not necessarily. And so I was really interested in knowing how burn severity correlated with fire effects and fire behavior that we could measure. What I really wanted to try to get at is, like, can we use this to infer how fire might be changing across the landscape through time, or how are some effects linked with different amounts of energy release, so that having that fire behavior element gives it a mechanistic part. So we had to go measure fire behavior and fire effects or burn severity, and so this past year we went out and measured fire effects in New Jersey at the Franklin Park Reserve, at the Tall Timbers Research Station, and where we measured those effects, we had paired fire trackers. And they're these neat little widgets that our colleague in University of Edinburgh built, and they measure where the fire is when. They've got a neat little GPS in them. You just bury them out in the forest, and this thermocouple sticks up, and so we laid them out in a grid in plots like this. This is the whole thing with the burn unit, and we can download that data and put it all on the computer and look at how hot the fire got in certain areas, what the residence time of the fire was in certain areas, how fast it moved, and then make another pretty map like that. And so here's residence time, and here's our burn severity. And so if you plot the two together, so this is all data from two fires in New Jersey and one fire at Tall Timbers. You can see what this means, if you're not into statistics, is that there's a line. The points kind of make a line, and that's a good thing. That means that there's a high correlation there. It's not the greatest correlation. 0.59 on a scale of 0 to 1 is pretty good in ecology. But that shows that there's a link there between severity and fire peak temperature. And then this is also residence time on our x-axis and severity here on our y-axis. And the relationship isn't quite as strong, but there's still a relationship there. And so what that means is that these maps have some, you can infer something about how the fire was behaving differently there, like you might expect. So the fire effects that I was focusing on were tree mortality. And I had gone around and I had to measure trees for about 30 different prescribed fires that had occurred across our landscape to estimate canopy fuels. And then I'd also measured, there were some wildfires, so I decided to go out and measure trees there as well. So here are my plots. I want to look at how burn severity correlated with tree mortality. And so we measured about 2,600 trees in 96 10th acre plots across 35 burns, I think. And this is what really came out of it. So on our x-axis we have burn severity, and our y-axis we have the probability of mortality. And each of these different color lines represents a tree of a different diameter. And so what what I did is I took the plot data and the severity that occurred there, and I created a model that said, if you know what your diameter is and your height, it was kind of hard to incorporate everything, height on there as well, so I just been focusing on diameter. But if you incorporate height, diameter, and that pixel value from your burn severity map, you can estimate with about 90% accuracy whether or not your pitch pine tree died. So this was all in pitch pine forest, to keep it simple. And so this is a 5 centimeter DBH tree here, and this is a greater than 30 centimeter DBH tree here. And so what this is showing is that it takes a lot less fire severity, a lot less effect to correlate with tree mortality of a smaller tree, which you would expect probably. And physically, smaller tree is going to have thinner bark than a bigger tree. It's not going to insulate as well. It's going to be shorter probably, so its needles and small branches are going to be more vulnerable to injury. One caveat is that this tree mortality was as a first order fire effect. So this wasn't, did beetles come 3 years later and kind of whittle away at it. This was surveys about a month after the fire. So what you can take from that is this is a burn severity map of a burn that we did this spring. The entire Franklin Park Reserve burn from this year is about 1,500 acres, and we've got our nice color-coded gradient of severity, but we could reclassify that as a mortality map or probability of mortality. And it's pretty simple to do. You just classify groups of pixels into ranges, and so everywhere that's red, we're looking at our 5 centimeter DBH tree here. Everywhere that's red, you would have had about 50% mortality of 5 centimeter DBH trees. And everywhere that's dark green really had a very low impact, and you'd only see really just the same background mortality of about 1% of those trees. And so if you integrate all this data, all these pixel values, assuming that you have 5 centimeter DBH trees there, you can come up with an estimate that about 24% of your 5 centimeter DBH trees across this site would have gotten whacked. And so you could go through and estimate that for your other classes of trees and figure out, how much, if you were trying to thin the forest, how much did you thin the forest? Did you thin what you wanted to thin? Do you need to change your prescription to kill a little bit more or kill a little bit less next time? So this is just an interesting way to measure something or estimate something. It can take a lot of time in the field to measure. The data to create maps like this is freely available from the USGS. If you have GIS software, it's not that hard to create a map like this. Downloading the data, you create a little login, and you can get it for free. And what's cool is that you can go back as far as 1984 and get data to calculate maps like this. One limitation is that the pixel size is 30 by 30 meters. So that's approximately the size of this room. So if you're doing small burns, this is kind of too coarse a tool perhaps for some places in the Northeast. But you've also got a field sheet you could use. So I didn't really describe this earlier, but I also went out and I measured, I took some of that data going back 10 years, some of that satellite data, and I looked at fires that I hadn't actually been to. So I incorporated about 450 wildfires and prescribed fires from that data. I looked at their severity, and I plotted them out by month. And I just sort of reclassified that severity by into four classes instead of a messy continuous spectrum of severity. And what you see is a strong seasonal component to severity here. And so as the year progresses, this axis is supposed to be months, but January and February got lost. But as the year gets closer and closer to the middle, our severity peaks for the year. And then as we get farther into the cold season, severity kind of plummets. And so again, if you're trying to get a desired effect, or if you're concerned about the effects that your wildfire might have, maybe you're trying to reduce wildfire because you don't want a particular effect. Maybe you want to maximize the area burned in wildfires with fire use tactics because that's the time of year that you can get the effect that you want. You can start to kind of make inferences about how fire is impacting your landscape with time, or how your management across a broad area is impacting the landscape through time. So I'm not sure if I'm doing it on time. I think I might be a little early here, but if anybody wants to talk about this later, I'd be happy to talk about it. But just to conclude, burn severity is linked to fire behavior, and there's data to show that. This year, I'm going to be collecting more data at tall timbers, and we'll be collecting more data in the pine barrens. I'm hoping to collect a little bit more data during the growing season and kind of fill out that end of the spectrum. But nobody's actually empirically linked fire behavior and severity yet, so this is kind of cool for it to be kind of ahead of the curve in the East here with something like this. So higher severity means that you've got probably a higher temperature, longer residence time at that location, and tree mortality closely follows burn severity, and seasonality can constrain the range of severity possible in your burns. And also severity may not be the best tool. Like I said, it might not really help you figure out anything about smoke. It might not help you figure anything out that doesn't jive with the scale of those pixels, or that's just a binary response, like the fire happened or didn't happen. There's a lot of mechanistic things that are really require the use of just a plot in the forest. But for monitoring type questions and integrating what's happening over a broad area, this gives you a way to sort of expand from just having a fire perimeter if there was or wasn't fire here, because we were kind of talking the other day about how not all fire is the same, and so this kind of can give a way to fill in that perimeter with a little bit more information about how one fire varied from another, or how one area of the fire varied from the other side of it. So just future work. This work really needs to incorporate more data from different seasons, especially in the pine barrens, and so hopefully this year we'll do that. Maybe I'll get out on some burns with you guys and deploy a couple of these instruments. But that's about what I got for this. We're also doing a bunch of other work that Nick's probably going to talk about some of that with how to measure fuels and stuff like that. So if anybody's interested, please come see Ken, Nick, or I, and ask about what else we're doing. Anybody have any questions? Yes?
So on your higher severity fires, did you find with the mortality of the trees, did you have more duff consumption?
We didn't measure duff consumption, but I would say no, because there were a lot of plots. This held true in both the dormant and growing season. In New Jersey, even high severity fires really don't consume much duff, if any. The soil moisture, the moisture is just such that it really limits how much surface fuel burns. It just never really gets in there. So most of that effect is all, in the canopy that you're seeing. So among different severities. So for instance, a fire that consumes the whole canopy of the tree often has a similar level of consumption of surface fuel as one that, just scorches them a little bit. Yep, Adele.
The scatter plot was tighter for temperature and residence time. Did you threshold residence time at a certain temperature?
I didn't. So actually, Eric Buebler, our collaborator at University of Edinburgh, extracted that that bit of the data for me. I'm not exactly sure how he did it. And there's probably some other ways we can spin that data to look at things like rate of spread. But yeah, that's kind of a sort of preliminary results. And then as we collect more data, we can kind of look at thresholding more. But that's a good question. Yeah?
When I looked at that map of the Warren fire, I was looking to see if there were any other areas. I was wondering if it crossed an area that burned before, if there was difference in severity. And before you answer that, the last slide, which is that showed up there, you have a big career, long-term coming up. Get a big area, do a couple real big burns in there in different years, and then burn the whole place years later. If you can show the severity, you can put 2018 on it, 2019, 2020. That would be incredibly valuable. One picture could show what managers need to do on the ground in pitch pine barrens, and you don't need any graphs. That was supposed to be.
So that's a good question, and I have started looking at that. One of the challenges in our neck of the woods, or maybe anywhere, is that the fuels grow back so quickly, and so you saw in the figure that a lot of the fire is actually fairly low severity fire, and what I found is that and seasonality is really important. So most of our fires. Basically, it's really hard to measure it. I've spent a lot of time thinking about it, but if you have a fire that burned, a cool fire that burned 2 years ago, or a hot fire that burned 4 years ago, it gets really hard to tease apart some of how that plays together. Because that was one of the first things I looked at, and it does become more complicated to figure out just how that all plays out. So a lot of our fires end up being, we do have some cases where a fire burns into an area that burned recently, but more often than not, those areas end up serving as like the buffers of the next fire. And so we're not really finding as much fire burning into a burned area as that burned area is serving as the edge of the future wildfire. And that kind of jumped out at me. So those places makes good holding ground, but we're not always reburning, and maybe with the stories is that they're not as flammable and they're not catching on fire from embers and stuff as readily either. But I need to look at that more because it is a very interesting question. I agree it could be pretty powerful. Also looking at the duration of an impact. So, thanks.